Welcome to online lecture session of SBST. The topic I am going to discuss is boiler performance. Boiler basically it is a closed vessel which is used for making of steam. So the performance of boiler is defined by its term evaporative capacity. Evaporative capacity of two boilers cannot be compared unless both the boiler have the same feed water temperature, working pressure and fuel and final condition of the steam. In actual practice, the feed water temperature and working pressure varies considerably. It is obvious that the comparison of two boilers becomes very difficult unless same standard feed temperature and working pressure is adopted. The feed temperature usually adopted is 100 degrees Celsius and the working pressure as normal atmospheric pressure 1.013 bar. It is assumed that the boiler is supplied with water at the boiling temperature 100 degrees Celsius corresponding to the atmospheric pressure. So the equivalent evaporation basically it is the amount of water evaporated from feed water at 100 degrees Celsius and formed into dry and saturated steam at 100 degrees Celsius at normal atmospheric pressure. It is usually written as from and at 100 degrees Celsius. As water is already at the boiling temperature, it's require only the latent heat at 1.013 bar to convert it into the steam at temperature 100 degrees Celsius. The value of this latent heat is taken as 2253 kilojoule per kg. Mathematically, it is expressed by E, that is the ratio of total heat required to evaporate feed water divided by this latent heat value, where this H is the enthalpy. For different steam, you will use this particular formula in order to have the enthalpy value. And the mathematical expression for this evaporative capacity, it is ME into H minus HF1 divided by 2273, where ME is the mass of the water actually evaporated or the produced in kilojoule per hour or kg per kg of the fuel burnt. So we know that the heat required evaporated 1 kg of water is equal to H minus HF1 and the factor H minus HF1 divided by 2257 is known as the factor of evaporation and it is denoted by Fe. Its value will always be greater than unity for all boilers. Boiler efficiency. It is defined as the ratio of actual heat that is used in producing the steam to the heat that is liberated in the furnace. It is also known as thermal efficiency of the boiler. Mathematically, it is represented by ME into H minus HF1 divided by Cv, where ME is the mass of the water actually evaporated or actually evaporation in kg per kg of the fuel, and Cv is the calorific value of the fuel in kilojoule per kg of the fuel. So, if we take one problem for this particular topic, the boiler evaporates 3.6 kg of water per kg of the coal into dry saturated steam at 10 bar and temperature of feed water is 32 degrees Celsius. So in this particular question you have to ask, they have asked find out the equivalent evaporation and the factor of evaporation, these two. So as you know, the value that is given for this particular problem that is given in the question, ME is 3.6 kg per kg of coal and pressure that is given 10 bar and feed water temperature that is given 32 degrees Celsius. So what you will do with the help of steam table, by using the temperature scale table, you will find out for 32 degrees Celsius what is the value of enthalpy. So you will come out to this value 134 kilojoule per kg and corresponding to the steam pressure that is given in the question is 10 bar. Again you will see for saturated steam the value it is, you will see in that steam table it is going to be 2776 kilojoule per kg. So by using the equivalent evaporation formula and putting all the values, the result will be coming out to be 4.2 kg per kg of coal. And easily you can find out the value of factor of evaporation also. It will coming around 1.17. As already discussed in that previous slide, the value of factor of evaporation, it will be always be greater than humidity. And the second problem, in this problem, coal that is used, that is 250 kg of that calorific value is 29,800 kilojoule per kg, and water evaporate 2000 kg steam, and pressure that is given 11.5 bar, and dryness fraction of the steam X is given 0.95, and feed water temperature is 34 degrees Celsius. Again they are asked you to calculate the equivalent evaporation and the efficiency of the boiler. Again you will see the FF mass of the fuel that is given to 50 kg and mg is given 2000. So easily you can find out the value of me. So me is equal to mg by mf. So mg as per the quotient value that is given 2000 and mf it is 250. So value of me will be coming around 8 kg per kg of coal, and you will put up this value and find out the value of these three things. The feed water temperature that is given 34 degrees Celsius, this value will coming, and at pressure 11.5 bar you will get this value of HF and HFG. So you, as it is the region of the wet zone, so you will use this formula. Okay, try this formula. So that will coming up the enthalpy value 2681.8 kilojoule per kg, and value of the equivalent evaporation that will be coming 9 kilojoule per kg of coal. And finding the value of the efficiency of the value of the boiler by using this mathematical expression formula of the boiler efficiency, the efficiency it will be coming around 68.2. So this is all about today's session class. Thank you.